So this is our new chapter, which is gravitation. So how everybody, how was the test? Everybody, I'm audible. How was the test? The test on which was on Friday, basically.
Yeah, it was understandable.
Understandable. Okay, how
Yeah.
many of you gave the test? Nabila, I got your answer sheet. Aris, I got your answer sheets. Only 2 students. Okay, as Arya is new and Galvin is also new, so no issues. So that's great. So how many of you have a little bit idea? You can say any what is basically gravitation? How many of you know about the word gravity? Like any basic idea, whatever you have like in your mind when you
The force which Earth pulls us, any object.
okay, 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 okay. Okay, so gravitation force is applied on only humans or like it's applicable for the whole universe?
The
Like
universe.
Universe.
Very good. It's great. Just let me. Okay, so our first topic will be universal law of gravitation. So, how many of you have watched the finals of today's match?
A bit, sir.
A bit, okay. What do you think? India will win or lose?
India did not play very well at the start.
Yes, that's true that India didn't play at well. Like in the start, they were playing very well. Now they have also got a decent start with the bowling as well. Like they have got the first wicket of the opener of the Australian bats team. So let's see. Let's hope for good. Yeah.
Yes, sir.
Sorry. Okay, so I think they are not gonna join today, the other rest. And okay, let's start without any delay. Okay, so sorry. So everybody, let's start with the word first, gravity. Okay, so what do you mean by gravity?
Force that pulls objects downwards
Okay,
to
and
its
then this.
center.
Okay, that's great. What about rest? Arya, Galvin, any idea? Whatever you have in your mind about the gravity word. Okay, so basically gravity is nothing but gravity is a force which is exerted by the earth to attract the object toward itself. Clear? Yes or no? Because how we are able to move on the ground? Because of the gravity, because earth attracts us towards the ground. Earths want that we should stay at the ground. So suppose one thing, if you jump on the ground, will you continuously be in the air or you will come back to the surface again?
Come back to the surface.
Come back to the surface.
Come
Why?
back.
Because of the gravity. Because gravity says that gravity wants that you should be at the ground level. Okay, basically gravity attracts us, the earth exerts a pressure. Very good. So basically sorry, so you can say, and one more thing, the most famous example of the Newton, like Newton, Sir Isaac Newton was sitting just like you can say underneath a apple tree, and an apple falls down, and then that's how the gravity is discovered. Like see, just the normal, like that was a normal occasion, but the most important, or you can say the most fascinating the term gravity is
Good.
introduced at that time.
Sorry for being late.
Okay dear, no issues, but try to be on time. I've just started. Okay, is that clear? Yeah. So so earth attracts toward its center to every object, whether it's you can say small or large. Okay, that's the force of the earth, and that's called the gravitational force of earth, which is called gravity of earth as well. Clear? Yes or no,
Yes.
everybody?
Yes, sir.
And
So,
basically, one more thing, the gravitational force of earth is also responsible for holding the atmosphere of the earth. Just like you have seen now, we have an atmosphere in the upper, like in this, you can say the lower level of your the earth, troposphere, atmosphere, these things. So gravity also is responsible for holding that atmosphere in the sky, in the basically above the ground. Clear, everybody?
Yes,
yes,
sir.
sir.
Yeah, very good. Have you seen that that why there is so much high tides in the, you can say, in the oceans?
Because of the moon.
Yes, because of the gravity of the moon. Just see that thing. Okay, so we'll be like we will be taking those concepts in the later part of the class. So first, so I've that's what basically the introduction of the gravitational force of earth. Clear, everybody?
Yes, sir.
Yeah. So so let me write this thing. The force, the force with which two objects attract. Hello, Alvina, how are you? Each other. Alvina, are you there?
Yes.
Why are you
Yes.
late, Alvina?
Sorry, sir. I didn't see the time.
Okay, it's called. Clear? That's what the gravity is basically. So one more thing is that basically the gravity depends on the mass. If the mass of the basically the masses of the objects are very small, so basically the gravitational force between them will be small as well. Okay, clear everybody?
Okay.
Yeah.
Yes, sir. Yes, ma'am.
And now you've seen that thing, like Earth, Sun, and all the other planets have so big size, right? So that's why the basically the you can say the gravitational force between them is a little bit higher. So that's why our whole solar system is in stable condition because of the gravity. The gravitational pull is, you can say, sufficient to hold the whole solar system and a whole universe as well, because in everywhere everything is connected with the gravity. Okay. I'm audible, everybody?
Yes, sir, you're audible.
Okay. So basically, let's understand the first law of the gravity, basically the gravitation, which is universal law of gravitation. Okay, so basically this says that thing, basically first law says that thing, that the objects basically are directly proportional. Let me write it down first. Every body in the universe, that's why it's called universal, because this whole this law is applicable to the whole universe. Clear, everybody?
Yes,
In the
sir.
universe attracts every other body every other body with a force and a force which is directly proportional to the product of their masses okay, and inversely proportional to the square of the distance between them. Sorry, everybody. Actually, I'm not well. That's why my writing speed is slow. So sorry for that. Okay.
It's okay, sir.
Yeah. And sorry for my bad voice as well. Like I have a little bit cold as well. So I'm not able to speak a little bit louder. So please
It's
adjust.
okay,
Yeah,
sir.
thanks. So basically, for universal law of gravitation says that thing, that force, the gravitational force between the objects, basically suppose that two objects are attracting each other. Clear? So the
Yes,
force
sir.
is directly proportional to the mass of the to the product of the objects, basically. So two objects will have their masses as well. Yes or no, everybody?
Yeah.
Yeah.
Yes.
And basically the product of their masses, okay, and inversely proportional to the square of the distance between them. That's what the gravitational laws, universal gravitational law says that thing. So basically, let me write it like this. Okay, so first condition is this, and second condition is F is inversely proportional to the 1 by R square. Okay, so basically if I merge those these two equations, so it will become F is directly proportional to the mass product of their masses divided by the square between, basically the square of the distance between them. It says that if the product of their masses will be high, everybody look at the screen first, note it later, this is very important. So whenever the product of their masses will be high, it means that basically the force will be very high. So you have seen that Earth has a very high mass and Moon has a very high mass. Like in the solar system, every body has a very high mass. Clear?
Yes.
And but if their distance is very high, it will also affect. It means that suppose that distance, now suppose that thing. First of all, let's take one example. This is force F1. Clear, everybody? Just a second. This is your force F1. And F2 will be force like this, M1 and M2. Then the distance between them is twice the first one. So it will be what? F2 will be basically M1, M2 divided by 4R square. So now see that thing, everybody. Your force becomes 1 by 4 if you double the distance. Basically, your 4 reduced to the factor by 4. Basically, if you are saying your force is 1 Newton, if you basically double the distance, your force will become 0.25 Newton. See that thing. How much is the decrement if we increase the distance between them? Because distance between this formula has the square distance, not the distance, only square of the distance between them. Clear, everybody?
Yes, sir, it's clear.
It's any doubt, everybody?
No, sir.
Okay.
No, sir, there's no doubt.
Okay. So let me raise this thing first. So if you basically remove this proportional sign, whenever you remove proportional sign, one constant will be introduced in the equation. Okay. So this will be like this. F is equals to E M1 M2 by R square. So this G is basically the universal gravitational constant. What is called it is universal gravitational constant. Clear, everybody?
Yes, sir.
Yes.
Yeah, it's clear.
So basically, the scientist measured the value of this constant, universal constant, and this constant will be same throughout the whole universe. It will not change. The value of this constant will not change. This constant G, the value of G is 6.67 into 10 to the power minus 31 kg Newton meter square kg to the power minus 2. Clear, everybody?
Sir, it's 10 raised to the power 3 or 4.
Sorry, it's just a second. It's 11. Sorry, it's minus 11. 6.67 into 10 to the power minus 11 Newton meter square kg to the power minus half. It means that per kg square.
Sir, what is that again?
Per kg square. Clear? Yes, Arya, you are saying something?
What is that?
What is dot decimal? 6.67.
No. What is that?
This is, you are asking that
Yeah.
what is G basically. So
No.
Arya,
I'm asking what is the 6.67 into 10 raised to minus 7?
Arya, this is the value of this G. Scientists have calculated this value.
G is gravitation, right?
Gravitational constant. Gravitational constant. This is a universal constant which is basically comes into the picture when we basically remove this proportional sign.
Oh, yeah, got
Okay.
it.
Okay. When we remove this proportional sign, one G, basically this constant is introduced, and scientists have calculated that the value of this G is 6.67 into 10 to the power minus 11 Newton meter square per kg square.
Okay, got it.
Okay. That's what the value of G. You just have to remember this value.
Okay, sir.
Is that clear, everybody?
Yeah, it's clear,
Yes, sir.
sir.
Any doubt?
So,
No,
No.
sir.
Sure?
Yes, sir. Confidence, sir.
Yeah. So basically this value is calculated how? Nothing but the distance, basically the force between the objects is also sorry. Okay. So next thing will be so whenever, so this whole G value will be applicable to the whole universe. It will not change throughout any universe. Like if you are calculating the force between Earth and Sun, this value of G will be same. If you are calculating the basically the force between Sun and Moon, this will be same. If you are calculating with basically the force between Sun and you can say the last one is I think Uranus, the last planet in the solar system. So this will be same. Clear? This G
So
value will not change.
is capital G only for big masses?
I didn't get your word.
Is capital G only for big
No.
masses?
It will for everybody. It will be for everybody.
Oh, okay.
Like if we are basically right, I'm said like basically I'm there, and suppose that in front of me that's my laptop. Okay, so it will be also attracting me. Okay,
Oh, okay.
Yeah.
with the same force. So G will be same for everything, whether it's pinpoint, whether it's mass. Like it can be like 10,000 kg, or it can be either 1 kg or 10 gram as well. It will be same for everything. Clear? That's why it's called
Okay.
universal. Universe means it consists of everything in the universe. It covers all the basics. Clear, everybody?
Yeah.
Yes, sir.
Yes,
Any
sir.
doubt?
No,
No,
sir.
sir.
Okay. So basically, yeah, very good. Now let's come to the point. Basically, how the basically the gravitation and how our universe, basically the solar system is in like in a circular motion. Okay, let's see this thing here. So basically, a force is called, let me just a second, let me write it down first. Centripetal force. Okay, centripetal force, let me tell you what is basically centripetal force. Suppose that this is the okay, so this is our basically solar system. Just a second. Okay, so this is our solar system and this is sun. Clear? And this is
Yeah.
sun. So basically, and our earth is like here. Clear? This is
Yeah.
our earth. So basically, sun will also apply some gravitational force to the earth. It will also exert, because every object exerts the pressure or the force.
Yeah.
Yes or no?
Yes, sir.
Yes, sir.
Yeah. So basically, there is a force between them. And basically, this force, basically the circular motion due to the force which is towards the center of this circle, which is basically the basically the sun, where the sun is placed. So this will go in this direction, just like the circular one. If there is no force between them, so this force will be like this, motion will be like this. It will be tangent to the circle. Tangent, I will tell you what is basically tangent, because that's a
Tension is a line touching the circle only at one point.
very good, very good, very good, very good, Reem. Tangent is the point of contact at only one point. Very good. Clear?
Yes, sir.
Yeah. So if there is no centripetal force between the sun and earth, basically centripetal force is working as the gravitational force here. Clear, everybody?
Yes, sir. It's clear.
Okay, so that's how the all the planets attracts each other and basically forms a circular orbit. Clear?
Yeah.
Any doubt?
No, sir.
And this force will be towards center, whether the earth like basically like earth continuously revolve around the sun, whether its earth is placed here or whether its earth is here, anywhere the of this force will be towards the center. Clear, everybody?
Yes, sir. It's
Have you
clear.
seen that thing? You have a thread and you have tied a
Yeah.
stone to the end of the thread, and you continuously
Yes.
move this
Yeah.
way. Okay, when you lose basically that lose that string, it will go in the straight direction. Rather than moving in the circular movement.
Circular.
Yes or
Yeah.
no?
Yes. Yeah.
Why? Because the direction is in the tangent. It will go in the
Yeah.
straight line.
Right.
That's like if you remove this force, the earth will go in the straight line. Same with the moon, same with the Pluto, same with the Mercury, everything.
Yeah.
Clear, everybody?
Yes, sir. Yeah.
Very good. Very good. Very good. So I hope that's
And
clear
it's
to you.
also used for making curd.
Making
This is also used for making yogurt.
yogurt. Basically, yogurt there is already yogurt
No,
is
no. I think some dairy product though. It's like
that's
there's a
butter.
machine.
That's butter.
Oh yeah, it's for
But
butter.
yeah, but that force is not centripetal. That's a centrifugal.
Oh, okay, never mind.
Yes. Centrifugal force is the opposite of centripetal. It goes away from this body.
Yeah, I
Yeah.
realized.
Okay. Have you seen washing machine? How many of you have seen washing machine? The dryer of the washing machine.
I have seen that.
You
I
have
have.
have you like basically have you ever observed that how does the basically the you can say the clothes become dry when we put that into the
Yeah.
dryer? Is there any
Yes, sir.
heater inside the washing machine? No,
No, there
na?
is no.
Only the spinning movement. Basically, whatever the water particles are still there in the clothes are become outside of the cloth due to the centrifugal force. This centrifugal force basically out to outside the body. It says that suppose that this is moving like this. So every body in the circular motion will also have centrifugal force with the along with centripetal force as well. When we basically
Yeah.
travel in the bus, when we go in the circular direction, we basically go outwards with the bus.
Yeah.
Yes or
Yes.
no? Suppose
Yes,
that
sir.
bus is going in this direction, so we'll go in this direction if you sit in the bus. Yes or
Yeah.
no?
Yes.
So that's what the centrifugal force is. So that's how the centrifugal force is used to basically separate the butter from the cream and washing machine. Clear, everybody?
Yes, sir. It's
Okay,
clear.
Yes,
that's
sir.
great. That's great. That's great. That's great. So let's calculate a simple numerical. Okay. So that's the first numerical, everybody. Look at the screen. That's how basically, let's look at the screen, how to solve these things. Clear?
Yeah.
So basically, we need to calculate the force of gravitation due to Earth. Basically, that means that force exerted by the Earth on a ball of 1 kg. Suppose that I have one ball. Right now, I don't have any ball. I will because you have seen that ball. It's of around 1 kg. Like ball
Yes,
usually
sir.
don't weight 1 kg. So only the mass is supposed to be 1 kg. Okay, lying on the ground. So ball of 1 kg is lying on the ground. Okay, we have to calculate the force. Clear, everybody?
Yes,
Everything is
sir.
given here. Mass of Earth is given, which is 6 into 10 to the power 24 kg.
Okay.
Suppose M1 is the 6 into 10 to the power 24 kg. It's very high mass. R, basically the distance, the radius of the Earth is 6.4 into 10 to the power 3 kilometer. So what is basically, if I need to convert this into meter, what I need to do?
Multiply.
Multiply with
1,000.
1000, because in 1 kilometer 1000 meters are there.
Yeah.
Yes or no?
It will be 10.
Yes, sir.
6.4 into 10 to the power 3 into 10 to the power 3, because 1000 is nothing but 10 to the power 3.
So 10
this
is the
will
power
be
6.
10 to the power 6 meter. Because see that thing, gravitational constant has meter in the SI unit. So it means that everything should be in SI unit. Kg is SI unit, okay. Kilometer, no SI, it's not in SI unit. We have to convert this into SI unit. Clear, everybody?
Yes,
And
Yes, sir.
M2 is 1 kg, the mass of ball. Yes or no? Let's
Yes.
put into the formula, which is G M1 m2 divided by r square. Clear? So it would be G is what? 6.67 into 10 to the power minus 11 into 6 into 10 to the power 24 into 1 divided by square of the distance between them. 6.4 into 10 to the power 6 divided by, not divided by, to the square. Clear everybody? F is equals to, so let's 6.67. Now see everybody, base are same. The value will be added or subtracted if the base are same.
It will be added.
It will be added. Very good. 6.67 into 6 into 10 to the power minus 11 plus 24 divided by, because 24 isn't positive, na? Yes or no, everybody? At least respond.
Yeah.
Why is everybody so silent in the class?
Like I'm silent because I'm trying to understand.
Okay, at least, okay, everybody. At least try to respond me whenever I ask some question. Okay, and 6.4. So can I write this as 6.4 into 6 into 6.4 because it's square. So 6 and this 6. What will you do? Will you multiply or will you add 2 to this 6?
We will multiply.
Okay, Reem said
Then we can
multiply.
add the exponent.
Okay, does you said Arya that we need to add the exponents.
I said Alvina.
Okay, Alvina said okay. What about Arya? R is Nabila.
We can add the exponent.
Okay, Arya said add the exponent. And Nabila, you said I add the exponent.
No, sir.
Okay, you didn't respond anything.
Yeah.
Okay. So basically, everybody, whenever there is an exponent like this and whole to the exponent, so this power will get multiplied. This will become 12. Clear?
Oh, you were asking about that?
Yes, I was asking about
Oh,
this.
I thought you were asking about the upper one. Never mind.
Okay. No issues there. No issues. So everybody got it or not?
Yes,
Yes,
sir. I
sir.
got it.
10 to the power 12. Clear?
Yes, sir.
Sir, can you just explain once again?
Which one? This one?
No, the whole part.
Okay. Nothing, Reem, nothing. This is nothing. I've just put the value 6.6 and 6 was there. And I have added these values because bases are same. And this is minus 11. This is plus 24. That's how I have added. Divided by 6 to the 6.4 into 10 to the power 6 to the whole square. It means that 6.4 will be written twice a times because it's a square.
Yeah, yes.
And this 6, if you basically you can also write this thing as 10.6 into 10 to the power 6 again, because 10 to the power 6 again will be written twice because it's a square. So basically your bases are same, so you can add these values as well. 6.76 into 10 to the power. What will be left here? Everybody tell me. What will be left here if you subtract 11 from 24?
It's 13.
It's 13. Very good. Sorry, it's not negative 13, it's positive 13 divided by 6.4 into 6.4 into 10 to the power 12. Okay, 6 plus 6 will be 12. Okay,
Yeah.
now everybody, this is 12. So can I take this in the numerator? The power will be like the power will be positive or negative if I take in the numerator?
Negative.
Negative. Negative. Whenever we take the power from the numerator to denominator, if the power is positive in the denominator, so it will become negative in the okay, and 6.4 and 6.4. Now bases are same again. Can I add them again?
So how do you put 10 into minus 12 on top, like in the numerator?
Okay, basically, dear, if your bases are same, there's a one
Yeah.
property of the exponents. It says that suppose that your base is m and your base is n.
Oh, you use
okay.
okay. I
Like
didn't
this.
know you applied that property. Okay.
Yes, am minus n. So if I take this step a little bit further, so it will be nothing but it will be same. 10, 13 minus 12 divided by 6.4 into 6.4. Clear?
Yes.
Any doubt?
Yeah.
So now 6.67 into 6 divided by 6.4 into 6.4 into 10 will be left, because 13 minus 12 is nothing but 10. Like 10 to the power 1, and 10 to the power 1 is nothing but 10. Clear?
Sir, this formula is like how to say? Uh,
Yes.
I don't know how to say, but it's this. The question is given as like in textbook.
Yes, it's
So,
given in textbook, like textbook, sorry, NCRT as well. Like it's the proper part of NCRT here. I'm not taking extra little, you can say.
yeah.
So this whole is basically the concept of NCRT. Okay. Now 6.67. Basically, if you are see this thing, this is 6.4. So if I divide this by 2, so it will be 3.2 and 2 3 is 6. Okay. If I also divide this by 2, so it will be 3.2 and 5. Clear, everybody? So what will be left here? It is 6.67 into 3 into 5 divided by 3.2 into 3.2. Clear? So F will be equals to if okay 5. Okay. If I divide this by 6, so it will be 0.64. Clear? So 6.67 into 3 divided by 0.64 into 3.2. So this will be basically becomes equals to the 9.8 Newton. So basically, if you take this value, if the one basically the earth exerts, that's a general question. If the earth exerts the 9.8 Newton force on a 1 kg of mass. Clear, everybody? If the mass is basically placed on the ground of the earth. Clear, everybody? At least yes or no? Is that clear to you or no?
Sir, one more
Yes.
time, can you say?
Arya, you said
Not
something.
clear.
I think.
Can you say it one more time?
Can I?
Can you say it one more time?
Okay, I'm saying that if one basically the earth exerts a 9.8 Newton of force on the ball, or 1 kg ball basically, if it's placed on the ground. Clear, everybody?
So can you just explain the second last step?
This one?
Yes.
Okay, basically
Before that.
like this one?
Yeah.
Okay, basically dear, 6.4 is the basically can be divided by 2. So I have divided by 2, 3.4.
Oh,
And 2 3s are 6. Okay, one more thing here, I have also multiple of 2, so which is 10, and 6.4 is a multiple of 2 as well. So I have divided this by 2, 3.4 is left, and 5 is left. The 2 5s are 10. Clear? 6.6 into 3 into 5 divided by 6.4 into 6.4, which is nothing but 2.2, 3.2 left and 3.2 left. So 3.2 and 3.2. If I divide this 0.64, like 3.2 by 5, it will be 0.64. So when you make up this equation, so this will be basically becomes equals to the 9.8 Newton value. Clear, everybody?
Yes, sir.
Any doubt?
yes, sir.
No, sir.
Yes, sir.
Clear now?
Yes, sir.
Okay. So basically you can say that when both the objects very big.
sir, is it a second law of gravity?
No, it's not. I'm just writing a statement basically.
Okay.
Large masses. Then they. So everybody tell me, gravitational force is a contact force or a non-contact force?
It's the contact force.
It's a contact force. Okay. What about rest?
Contact.
Contact force.
No, both.
Both.
Okay. Think a little bit again.
It's contact. Uh,
Yes, everybody.
So it's contact force.
Okay, you said contact force. Okay. Like, have you seen, like, basically, is there any contact between the two bodies? Are they basically touching each other or anything?
Yeah.
How? Like, they are touching basically.
Yes.
Okay.
Like to the like where I'm sitting right now.
You are sitting right now, and basically, basically, there is a person in your house as well. So, are you in touch with that person? No, no,
No. No.
no. But still, there is a gravitational force between you and that person.
Yes.
So, will there be any, like, so now tell me, is it a contact force or a non-contact force?
Non-contact
Yes.
force.
So
The both.
gravitation, no, gravitation is a non-contact force, everybody. Okay, got it?
Yes.
Got it or not?
Yes, sir.
Yes, sir.
I got it.
Okay.
So it can be both, right? Like main things are like it's touching something,
So,
like it's contacting something.
Reem, tell me one thing. Is it necessary to basically, is it necessary, you can say, what I mean to say that, like, is it necessary to be in touch if you need, basically, if you basically the existence of gravitational force? Do you need any contact with any of the thing? If I'm sitting right there, my besides me there are so many books. They are also basically putting some force on me. Is there any requirement of getting touched by the books to put some
No.
force? No, na,
No.
no, na. That
No.
means that everything in the universe, whether it's in contact or not contact, everything is basically exerting some force on it, each other. Clear? Now see
Yeah.
that thing. Sun and Earth have so like big difference. Basically, basically that's a very big distance between them, and still they are basically. And Sun is also, because of the Sun, Earth is in the round motion. Why? Because Sun gravitational force is very high.
Yeah.
Are they in contact with each other? Like they are touching with each other? No, no.
No.
Still, there is a how huge force between them. Sun is
Yeah.
able to basically you can say basically sun is responsible, basically that's why earth is moving in the round orbit around the sun, because the gravitational pull is very high. Clear? So that's why gravitational force is a non-contact force. Clear?
Yes, sir.
Yeah. Yes.
The gravitational force between earth and sun, like they are so huge bodies, they have so high mass. 6 into 10 to the power 4 kgs is the mass of earth, and sun, and the mass of sun is very high, like it's about thousands of or 10,000s of time greater than earth. Clear? So see that
Yeah.
thing there. So basically the gravitational pull, the gravitational force between them will be high as well. Clear?
Yes.
Okay,
Yes, sir.
everybody?
Yes, sir.
Okay, very good. Let's take one more time here. Let's take one more question here. Okay, because questions will be there in your school exams on the on this formula. And when I was in ninth, I didn't prepare for this topic, and same questions comes into the you can say exam. I was like completely blank. Like I thought that I should have done this, at least the numerical only, and that was a 3 mark numerical. So okay, everybody got it. So basically, this question is giving here the mass of
So
Earth. Yes, Reem.
the I didn't write it. The one you have written before.
What?
Yeah, this one I didn't write. I will write and can start.
Okay, okay. You can write in the later part of the class, Reem.
Okay.
Okay, so you see here, look at the screen first. Basically, the mass of the, we have to calculate the force between Earth and Moon. 24 kg. Mass of Moon is 7.4 into 10 to the power 22 kg. If the distance between them is 3.84 into 10 to the power 5, R is the distance. See that thing, 3.84 into 10 to the power 5 kilometer. And if you multiply it with 3, it will become in the meter. So 3.84 into 10 to the power 8 meter. See this thing, it's about 3,84,000 kilometer. 3,84,000 kilometer is a huge distance. And but still, the gravitational pull is very high. That's why they are circular motion. Got it? Now see that gravitational force is very, you can say very, you can say powerful force. Still, I'm sitting here, but I will be exerting some force to you as well. Nabila, Aris, Arya, and same goes with you as well. You are also exerting some force on me as well. That could be negligible. Like the value of that force even be like very small, 0.000 something, very small. But still, there would be some force between us as well. Okay? Everything in the universe attracts each and every body. Clear?
Yes, sir.
Yeah. So let's put the value of the force again, like the everything in the numerical. Okay. So F will be equals to G is 6.6, 10 into 10 to the power minus 11 into 6 into 10 to the power 24 into 7.4 into 10 to the power 22. Okay. Divided by R is 3.85 into 10 to the power 8 square. Clear, everybody?
Yeah.
Okay. Let's 6.64. Sorry, into 10 to the power. Now see, 6 into 7.4. See this thing.
484.
It's
3.84.
3.84. Okay. Okay. So see this thing. 10 to the power minus 11, 10 to the power 24, 10 to the power 22. They have same base. Yes or no? So can I add them? Minus 11 plus 24 plus 22. Clear, divided by 3.84 into 3.84 into 10 to the power 16. Clear, yes or no?
Yes, sir.
Yes.
Very good. Is equals to 6.67 into 6 into 7.4 into 10 to the power minus 11 plus 24 plus 22 minus 16. Can I take this in the numerator as well? And this would be minus 16 because the base is same, na?
Yes, sir.
Yeah, very good. Divided by 3.84 into 3.84. Clear. So now 24 and 22. 22. It is 46, 11 and 16. It is 27. Minus 6, 17. It's 69. And 1, it's 19. Clear? So this will be equals to 6.67 into 6 into 7.4 into 10 to the power 19 divided by 3.84 into 3.84. So basically this will be approximately equals to, let's multiply 3.84 into 3.84. So it's about 14.74. So 6.67 into 6 into 7.4 divided by 14.74. So can I say this thing? Into 10 to the power 19. So this will be approximately equals 7.4 and 3, 6. So if I take this, can I divide by 7.4 by 14? So what will be the answer? So basically it would be equals to 7.4 divided by 14.74. So it would be around 0.5. Like you can write this as 6.67 into 6. Approximately this will, if you divide 7.4 and 14.74, it will be approximately equals to 1 by 2. Okay, that's why I'm writing 2 in the denominator. Clear? So 2 3s are 6. So 3 6 18. So 6.67 is nothing but it's around 20 point. So 2 zeros are there, 2.1. Just a second. 3 6 18. So it will be equals to 20.1 into 10 to the power 19. So if I take one more 10 here, so it will be equals to 2.01 into 10 to the power 20 Newton. Clear, everybody? Is that clear? Yes or no?
Yes, sir.
Now see that thing, 2 almost, you can see this thing as approximately equals to 2 into 10 to the power 20 Newton. See this thing, 10 to the power 20 is a very huge number. 2 into 10 to the power 20. Just see how much the gravitational force between between Earth and Moon is.
Yeah.
Is it a very huge number, na?
Yes.
Got it?
Yes, sir.
So that's how you will solve this numerical. Yes or no, everybody?
Yes, sir.
Any doubt?
Sir,
No.
I'm not sure how to do it.
Yes, Reem, you are saying something?
Sir, I'm not getting like how to do from the starting.
How to do from the?
Like like reading the question and writing it. Like I'm not able to understand.
Reem, it's a simple question. It's asking to calculate the force. If it's asking to calculate the force, we just have to put the value of mass. Mass of the Earth is given. Mass of the Moon is given. Okay, and the distance between them is also given. So, and the value of G is as given as well. You just have to put the values here.
Okay.
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 Only these kinds of questions will be asked in the school exams. Clear, everybody? Now tell me, everybody, is that clear to you or not?
Yes, sir.
Basically,
It's
the
clear,
high
sir.
tides you have seen in the nights in the ocean. I think that everybody lives in UAE, so there is in UAE and Saudi Arabia. So there are so many seas right there. Just because Saudi and Middle East completely surrounded by the water, by the sea. So you have seen that high tides in the night. That's because of the gravitational force of attraction by the moon and the sun as well. Clear?
Yes.
Yes,
Got it,
sir.
everybody?
Yes,
Yes,
sir.
sir.
Very good. So that's what the first topic is, and then inshallah in the next class we will do the basically
Yeah.
the third, basically the free fall motion, the gravitational. Basically, you have seen that thing. Whenever a body basically drops from the atmosphere, it goes without any, you can say, oppose. It just continuously go downwards towards the earth surface. Like suppose that you are here is the building and you basically drop a ball, it will go here. Yes or no?
Yeah.
If you drop a ball, so that motion is called as free fall. So in the next class, we'll be
Yeah.
covering free fall and the third equation of motion. We will modify the third equation of motion, like all the equation of motion for the free fall, you can say, scenario. Clear? Like your equation will be this: S is equals to ut plus half gt square v square minus u square is equals to 2gs. So instead of a, we will be using g. Why? Because gravitational acceleration due to gravity will work on that motion, free fall motion. Is that everybody clear? Is everybody clear to this?
Yes, sir.
Yes, sir.
Okay.
Yes.
Any doubt? Because there is no force, na? Only gravity is working on that body, which is continuously basically falling from the height, from the height.
Yeah.
Yes or no?
Yeah.
Yeah, very good.
Yes, sir.
Is that clear now?
Yes, sir.
Yes. Yes.
Any doubt till now?
No doubt,
No.
sir.
Mhm.
Okay, that's great. So that's all for this class, everybody. Okay. So in the next class, inshallah, we'll be doing the free fall motion and the acceleration due to gravity, which basically. And after that, only two topics will be left. This is a small chapter as well, not a very huge chapter, not a very big chapter. So
Yeah.
thrust and pressure and buoyancy and Archimedes principle will be left after doing the free fall. So inshallah, in the next two classes, we'll be completing this chapter. Clear?
Okay, sir.
Okay,
Yeah.
sir.
Yeah.
Yeah.
Is any doubt till everybody?
No,
No,
sir.
sir.
So this
There's
chapter is
no
a
doubt.
little bit calculation based, and you have to practice a little bit. Okay.
Okay.
Any
Sure,
doubt?
sir. No, sir.
sir.
No
Okay.
doubt.
Okay, everybody. Thank you so much for joining me, and take care, because the weather is changing.